Okay. My name is Goktug, and people call me Goku for convenience, which I was the character Goku. So for about a year, I've been obsessing about Swift extensions in Swift, and I've been working with Swift since it came out, and went through all the UIKit and Foundation framework and try to extend them and make them as usable as possible. So I'm going to share with you what I've learned so far during this trip. So here is a textbook definition of extensions. Basically, I'll let you read that. Extensions allow you to add functionality into a class that's from another source. So if you're using a Cocoa Pot, or if you're using Apple's frameworks or any other frameworks, you can add functionality to that without having your direct access to the source code. And you can also add functionality to Objective-C classes by using Swift. So here's an example would be if your company is working on an Objective-C completely, and you only know Swift, and you want to add your functionality, you can use extensions to just extend those classes and add new stuff to them. So I'll go through what you can do with Swift extensions. So first, I want to see how the demographic is in here. How many people can write Swift code? Please raise your hands. Okay, down. How many people are not technical at all? Okay, about two, three people. I think we're gonna get a little bored. I'm sorry. It's gonna be a little technical. Okay, so and one more thing. How many people work in small teams like 5 or below? And the rest is large teams, I guess. Okay, just half an hour. Okay, so here's what you can do with Swift extensions. Add computers or properties or computer type properties. I'm going to show you a little demo of how I use it and give you basic examples, like really easy examples, even if you know low-level programming, like normal beginner level programming language, or Objective-C, you should be able to understand this. If not, if I'm going too fast or if I'm not clear, please feel free to point that out. I'll explain it. Okay, so a computed property. So what is a computed property? It's basically a property that before returning its value, you're computing its value. So here's an example of how we can use this. So in Swift, in iOS, basically you have to change your variables into CG float or double, or you have to, like this happens in all languages, you have to pass that from a type to another type. So let's say you have a double, and I'm just going to say you have a double. Okay, now we want to get this integer version of this. An easy way to do this is just my integer. So this gives you the integer value. Int. Yeah, great. So it's an integer. Now, usually you don't decide that if it's going to change into integer while you're writing code. Usually, you realize that you have to switch it to another type after you wrote code. So it's usually like this. I write my double and I should have made this an integer. Now I have to go back there and write this. And this is not fun. So here's a simple extension for that. extend the integer, and basically we're making a computed property. So R to int.
Maybe extend double?
Here we go. Write the
south. South. Gotcha.
Kind of first time doing a presentation to so many people. Okay, so instead of this, you can now make it var to it. It's right there. But you decide to convert it to integer, it's right there. And we can put it out. So this is a very basic way of using integer extensions to add, like, change the language or the core frameworks functionalities to fit your programming style. Now you might not want to change it to twin, you might do something else, like twin, like every language, like the language you came from, like either Ruby or Python or Java, C#, they usually have some different syntax. Maybe you're used to that and you want that to continue, you might change it to something else. That's all your choice. So now, what if you wanted to like change double to a string? Now I'm gonna a string, and I have to print it. I have to like make this, add this double inside a string. So before that, I will have to go write my double somewhere and go string. So we can do this as well to string extension. To string and now, instead of doing this, we can do the same thing, like my double to string, and voila. So this computer property is like the same thing as basically it's a function. You can it's the same as this to int. So these two are the same things. If you're like confused with syntax. So okay, what else can we do? Define instant methods and type methods. So instant methods are okay. So let's say I'm gonna delete these. So if you wanted, we had a string, let's say var my string equals group 1 is awesome because they are also less. Okay, so you want to, let's say you want to make the first letter of this capitalized. And there's no such functionality in Swift strings. And well, usually what you have to do is you go to Stack Overflow, and you follow, okay, this, and you come, you copy this, You don't know what this means. You don't know what this does. I'm reading your code, mastering dots. And you know that's not. When you come back to this code, when you read it again, you don't know what it does. So this is not working well. Okay. So that changes. And let's bring up my string. See if it works. Yep, it worked. Group one is awesome. Okay, now here's a better way to do it. You can write a Swift string extension and add an instance method to this. So here, what would we call this? And what would be a good method name for this?
Capitalize first letter.
Okay, cat.
Capitalize.
Yeah, is that correct? There. Okay. Okay, now put this here. So, okay. Work. So when you're changing a variable's structures variable, you have in a function you have to make that function basically a mutating function. But in class you don't need a mutating function thing. So here you can just go my string dot string. Calculate
What's the first one?
what? So the calculate string changes the whole everything. Okay, screw pump is awesome. And okay, now your code is more readable. And the difference between this extension and just a function that capitalizes first letter is this extension will work for like every other class. Wherever you have to do something in string and you want to capitalize it, you just go my string and just see and it's there for every person in your team. It's going to be there. Well, if you're in a large company, you might not want that. You might want some extensions in some private, like you might not want everyone to access this extension you made, so we could easily make like, here's a test class, and I put the string here, the extension here, and it's going to work. If I make this a private extension, it's only going to be accessed by this file, not class, only this file. So it's not going to work. So if you're working on large teams, larger projects, maybe you don't want to extend everything in as you want. Maybe we might want to make them private, and this is a good way to control that. So that is how we use instance methods. So okay, some other thing. Did you guys understand, or should I give another example of computed properties or instant methods?
Understood.
Good.
Okay. Sure. And so let's go here. Another way to use extensions efficiently is providing with initializers. So I guess everyone here worked with UI colors. So basically we go to initialize UI color. I just write UI color and it says red, green, blue. Oh, that's very convenient. It's there. But you have to to make red, I think it's like you have to make this. So that is red. You basically have to put the, it's a CG float that goes from 0 to 1. So it would be easier if you want to work with like more intuitive, if you just want to work with the hexes maybe other decimals, or just write it on an integer base. You might want to extend the initializer of UI color. So we write convenience in it because it's not the main initializer. It still has to call the main initializer, which is it doesn't autocomplete when you're calling the main initializer, so I'm gonna have to do this. Okay. So I'm just gonna call R and int, G int, and E int, and change this to R.
Need to put in your divisions again.
Ideas for G is fine.
Should I be deleted that to int? See, it's ints there. So let's see what this means. It means the CG float, so you're gonna switch this to CG float here. Okay, we can get rid of this and make UI colors easily. It's GB. And let's bring that out so you guys can see. It's not complete. So you can add this to subview. Does everyone use storyboards, or does anyone do programmatic UI views here? No, no programmatic UI views. So there it is. That color. You can change this to like something else. And like, let's say if you want to initialize a gray color from the start, like here's a good gray. Just get the gray. And then call this. So I'm calling the UI. I'm going to initialize it as gray. I want Did I do something wrong?
You need to cast the 250 back to CG float.
Excuse me?
Cast the 255 to CG float.
And that's it. Great, CG float.
So it's doing integer division inside there. So
Oh, yeah.
so
yeah.
like 200 divided by 255 is going to give 0, so you're getting a black.
Yeah, correct. We have to like make this convert this to CG float before we make any changes in it. That's the problem here. There it is. Okay. So like, what else can we do? Can define subscripts. So subscripts are the very rare case, like you don't use subscripts a lot. And you use them a lot, but you don't create new subscripts a lot. And here's how it would look like. So basically, as a subscript, if you don't know, it's what makes the array, how the array has this, like my array. Array is basically a subscript, and to make the syntax, we have to initialize it as a subscript. So I'm just gonna do that. So let's say I want to get the strings position. So usually, like, let's say, string again. And to get, let's say, which one is get the position, get the all character here, third character, we have to write something like this. Start. Wrong here.
You're just printing the index. You need to probably index into the string.
Q, that is 0, 1, 2, 3. So that is how you access a certain character in Swift. The reason it's done like this because it's about performance issues, and Apple really wants us not to use subscripts and access the position like a certain character like this. When you want to, you can easily like extend it to include your own subscript. So it will be like this. So here we're getting the character. This is the index, and this is the character. So we just want this. So we want to get the second character. So
Passing the index.
good. how you would use a subscript to, if you want to extend something using subscript, here's how you do it. There's not too much use cases you can use with subscript because like everywhere it's logical, Apple kind of made that. And so it's not a good idea to extend your own classes, your own code. It's better to just write it inside there. So let's see what else we can do. Try and make an existing type into a protocol. Okay. So the protocol is, so we can make like, let's say we have a UI color, and we want that like to compare two colors, like is black larger or than red? Like you have to make a logic for that. You can easily like calculate the pixels and say this one's larger. But I'm gonna make a simple example. If I'm moving too fast or too slow, let me know. So this is a comparable extension. So UI color, we just implemented, we just made it conform to this comparable protocol using this extension. So now it says the error just does not conform to the protocol. So we have to conform this. So this is the syntax of how we do it. So here, let's say, so let's say if it is, I'm going to make a basic logic. If the color is black, it's going to be bigger than red for some reason. So this, in here you can add your logic to compare two colors or two strings or anything. If you have a new type that you're using a library that someone else owns, you can extend like the conformity protocols and do stuff like this. So let's go. Okay. Is there any part in here you want another example, or are you guys over here?
You didn't define and use new nested types. What was that?
Yeah. So the new nested types, I didn't do that. That's basically nested type. Like you can define and like extend your enums and other stuff like that. But so I haven't actually worked with that, so I don't want to try it here.
Okay.
And there. And so when to use extend stuff in Swift. So adding additional functionality to Swift. Like you can add new functionality to the language Swift, and you can add new language functionality to UIKit and Foundation, which are what you build your iOS apps on, or Foundation if you want to build or 6 apps on. So you can additionally add additional functionality without, if you want to don't want to mess other people's code. So here's what I do. I download a pod from Github that hasn't been updated for a year. Or let's say it's been updated for every week. And if I change something in that code, I'm gonna have to update it again. So it's my changes are gonna be listed. And if I sometimes when you make when you add a new feature, and the person, the owner of the repo, does not like it, or if it's not going the direction they envisioned, then I'm gonna accept your pull request. So you can just extend Auto without touching their code at all and add new functionality to it. So what I do is maybe there's a messaging group, there's a chat box, and it doesn't have this extra button I want it to be at the top. What I do is I just extend it. I don't mess with this code at all, and I add my button on top of there. And you could with Swift code, it's not possible, but with Objective-C code, you could actually access, do a little hack to access private variables as well, using the key value stuff. And those are more advanced stuff. So here's another good reason to use Swift extensions, breaking down data, functionality, and delegate. So basically, let's say you got a UI read controller here, and we're going to extend it here. So this is only for to make the code more clean. It doesn't add any functionality. It makes it more readable. So I want to say my color and my number and stuff like that. This is where I put my data. This is where I put my functionality, and this is where I put my delegate. So if I want to conform this to a delegate, let's say delegate for some reason, protocol, it's gonna fail because we haven't implemented the required methods. Oh, it's just when okay. So usually you have the main class at top with the export properties, and on the second this is for your own classes, not Apple's classes. On the second part, you add your functions as an extension, and in the third extension, you add the delegated conforms to, so when the person looks, they see the difference between, okay, this is where all the data and stuff are, this is where the functions and the functionalities, and this is where we have the conform to other places. So it's just a visual thing to make the code more readable. And when not to use it, extend your own classes from another file. Don't do that. You don't have a reason to do that, and that is not what extension is created to do. You wanna keep all your class code in the same file if you write in it as possible. Only use extensions when you have to extend someone else's code or code you do not have access to. And I'm going to show you some examples for my repo. So this is it. Is it good enough? Okay. So I made this repo to include all extensions I use and all popular things out there. It's like the awesome iOS and those kind of series. It's like awesome extensions where you just have everything in one place. So this repo is not very useful for for basically people with large teams and large companies do not want to implement this because it changes, it extends a lot of classes that you do not want to be changed maybe. But when you're I use this a lot, I use this in my own projects and a couple of people use it. And in hackathons, it helps a lot because instead of doing the Stack Overflow search, you just press start and usually everything you want to do that you do a lot, it's right in there. It's right implemented in the code and you don't have to search for it, you don't have to do anything for it. So my friends just won a hackathon with $10,000 prizes using this, and he was saying this library helped me more than any of my other teammates. So that is what he says. So use it. Well, these are not extensions, but these are stuff you use a lot, and I created a different namespace for them, like app version, app builds, and presenting web controllers, screen width, height. And here comes the extensions. So some of them are outdated, I've been working this for more than a year, and sometimes Apple comes and implements the extension I already built in, and it just stays there. Sometimes I don't update it. So here's if you want to if you have a bool and you want to toggle it, here's an easy way to do it instead of saying no. So this part, the number extensions are useful. Right? So if the number is even, odd, positive, negative, digits, you get all of them in here. So you expect the UIKit or the foundation to include this, but if not, it's here. So here's how I do my for loops. Basically, instead of doing this syntax, the range syntax, which I don't like, instead of doing this, I just put range, 5.range, and it switches that integer to make it 0 to 5, and makes a for loop. So you have to convert between different types all the time, and this is just a more convenient way of doing it. It's more, I wouldn't call these more readable. The standard iOS way is the same readability as this, but it helps you get faster. You don't have to go back to the front of the line and change it. And this whole repo just makes it faster. And when you're making a quick prototype, that's what you need. So here are some double extensions, string stuff. There is the range, the subscript. So this is very interesting, the length. I think it was the last Swift update that Apple changed if you want to get the length of a string, you have to write string.characters.count to get the length. And this length is basically, let's check it out here. So string extensions. So that's basically what it's doing. It's returning the character count in here. Capitalize first, and if my string contains this, that, very simple stuff you have to use a lot, and you don't want to make it you don't want to implement a new pod for all these features. And so if trimming is something I use a lot, and if this is an email or not, the string that's entered, is it a URL, extract URLs, convert numbers, and there's getting random objects from an array or something else, getting the index of this object, which is very helpful, and removing objects. Instead of doing this, you would have to find its index point and remove that index array object. And this is more convenient if you know just a name. It does the array contain an instance of something or not. So it goes a lot. There's states, timers, CG rates. I do a lot of programmatic UI views. I think they're more, it's more extendable. I can, since I made a lot of projects, so it's more easy to use programmatic UI view controllers and views than storyboards or XIVs. So I did a lot of stuff with the UI view controller and UI views. So you can get like top of the view controller, tab bar, navigation bar, and I try to make these sound like as intuitive as possible. So the frames are like, instead of this, like so if you're making programmatic UI views, you have to initialize a UI view all the time. And usually the syntax to do that is, I did it before, like here's, you write UI view, go to frame, you write CG rect, and it doesn't autocomplete. I don't know why. So I have to write it exactly, and come here and autocomplete, then I write with my values. And instead of going through all that process, it's just an initializer. When I do this, it's just initializing UI view with that frame. X, Y, its height. So you can make the UI view construct from a super view. It has the same size of the super view, and you can add paddings to it, and a bunch of stuff here. How are we with time?
Yeah. Should we do questions?
Okay, let's move on to questions. It's like this goes on forever. Imagery response, device stuff. These device stuff are useful as well. System version, device modeling stuff. And block objects, which are the easy way to do with buttons. And that's it. Any questions?
What's your strategy for type checking or bounce checking? For instance, if you're passing a string, you want to convert to integer. And
What can I get that again?
what's your strategy for putting checking in the subroutines? For instance, if you want to convert a string into an integer and you pass it an S, what's your strategy for putting bounce checks within?
So if you can't transfer that, if I can't convert a string into integer, it's going to return. It's an optional, so it's going to return nil. Can't do this.
So you don't embed any kind of warning message or anything?
No, like it's nil. So like if it's returning an optional integer, so in that case you'd have to either check if it's nil or not, and make if cases for that, or you just go put an exclamation mark and just risk that it might crash. It might not be as integer. So it's up to the developer's choice at the moment, but the compiler warns you if there is.
It's 20 hours.
It's not laptop.
So I guess what you're saying is the built-in bounds checking are good enough for most applications. You don't find a case where you actually have to put some divide by zero checks, things like that, right? Programs are blowing up.
Couldn't exactly understand what you meant.
So do you find that the compiler itself and the tool set
Yeah.
does a pretty good job of
Yeah. Like if it's returning an optional value, if the operation is unsuccessful, it's going to return you nil, and you would have to handle that on your own code, not in my code. Like it's going to return, okay, this operation failed, deal with it. Some, like the case this fails, you have to deal with it in your code, and that's basically how like the new iOS stuff, all the standard iOS libraries are done at the moment. Hope I have answered your question. Okay, there.
How do you deal with some of the ambiguity that extensions like this can introduce? So, for example, the string extension .length, the existing characters .count gives me, like, I know from that I'm getting the extended graphing clusters. So I know that I'm getting a count of composed characters. Whereas if I was writing let's say something string bytes, I would want to know byte length. So is that more of a naming problem, or how do you kind of reconcile that ambiguity that's introduced by some of these examples?
So yeah, there's definitely some, I try to make it as intuitive as and clear as possible and add documents to it, and some of the contributors help with that. There's certainly some naming problems in some of those extensions, but the reason here is like, so a string that is going to return like a string character count that is going to return something that not working is a very low possibility. I haven't seen that case. Like there's some weird characters that you can use that might mess some of these extensions up, and if you do the Apple way, it doesn't mess up. Because you have to handle all those cases. But here, like so the thing is, do you want to spend more time to build a more powerful, a more safe product, or do you want to make it quick and you just want it to work as fast as possible with minimum amount of code? So that's why what this library is aiming for, not the safety of. Okay, other? Sir?
So I was curious, I mean, this is almost like bringing Swift to the Python language mode, right?
Yeah,
With
yeah,
stuff like
that's the idea.
and index race. So I was thinking, if Apple makes a change to Swift, new version change, whatever else, and they introduce terminology from your current extensions, you mentioned that you keep changing it, but sometimes you may not. So are you afraid that, I mean, you write your code and your code is at risk of breaking because Apple puts out a new version, and then you're opening up a project that's in a prior version of Swift, and now randomly things are probably not compiling?
Yeah, good question.
Do the extensions override the Swift language, or what happens?
It doesn't compile. It's just going to give an error because if they do the same thing, you cannot extend it. And I use CocoaPods, and even if it's in the CocoaPods, you cannot extend something that already has that is already being used. So it's going to break. It's not going to break. It's just not going to compile after that language change. And we're going to have to either update the extension library, or the user is going to have to comment out the extension, basically. And here we updated 8 hours ago. So there's probably a lot of pull requests just waiting for me. May I get home? Yeah, there is. So I have to handle all of these and just merge them. So like community is helping and making it better.
So before starting off with a new version of Apple, I would imagine, do you have like unit testing incorporated in here that you can just run and make sure everything works?
Yeah, that's it. Unit testing, there's like some parts are, some of the contributors are adding unit tests. It's not fully covered, it's like 10 or 20% I think at the moment. So that's on the way. If you want to contribute on that part, I'd love it. And there's Huawei, Apple also, since it's open source, like I get the question a lot, like, okay, Apple's open source now. Now these are why do this at all? Why not just go send a pull request to this official Swift repo? And the thing is like they're very slow at adding new functionality. It's like, and even any pull request you send, any feature you recommend, it's gonna take at least 6 months to go through the verification process, and because they don't wanna push it to millions of people very fast. So this is like a startup mode of Swift. So basically, it's moving fast, it's growing fast. I hope some people from Apple will come here, get some ideas, implement it, so we don't have to make extensions for those stuff. Any more questions? Thanks. Okay, no questions, I think. Oh, sure. No. Okay. Okay, that's it. Thank you for listening.
Yeah, thanks a lot.